Okay, it's actually 12:45 p.m. Saturday morning on the 14th of October. I built the breadboard circuit up on my Bubbleator dual frequency oscillator circuit using a NE556, using a multiplexed signal. So basically, I'm sending two separate frequencies into two separate driver transistors, which is basically underneath that resistor down there, which is the that's a BC182L NPN, and this is a BC212L PNP. So basically, originally the circuits that I was using this circuit, which is basically tip 122, and then I changed it because the gain wasn't very good. So I swapped over to BC182L, and I also changed this one to BC212L. And also, whereas the emitters are actually connected together in this configuration, which is a circuit I found online. This part is anyway. Just this top section where I'm looking at right now, this data here, nothing else. I actually had a bit of a conundrum because I wasn't able to get enough output on the main capacitor, which drives my coil. Anyway, I did a bit of sketching. Now, one of the problems with driving a transistor configuration like this, which is just a scribble I've done, is that what can happen is that the voltage from the plus supply rail can travel down a PNP emitter through a diode and a resistor and loop back and bias the NPN at the bottom and cause a short circuit. And that was a bit of a problem. And then I realised, oh, hang on a minute, actually my circuit isn't quite the same, because what I'm using is two separate transistors. I'm actually using two separate, the biasing comes through the 4.7K resistor. I'm actually using two separate transistors, which are actually back to back. Well, the emitters are connected to separate diodes. So the supply is separated anyway. So I was able to utilize my circuit, which would normally not work. So this circuit, which I actually incorporated into my schematic, actually made it possible for me to use this configuration. And the current was a lot higher on the Q1 PNP, so I had to put this heatsink on. And the heatsink actually keeps that particular transistor cool, but the NPN is actually running fairly quiescent, actually. It's not running bad at all, so I don't actually, I'll get my magnifying glass. I should be able to see it better with the magnifying glass. See, I don't want to short anything out. Right. So basically, that's a tip 41C, and the PNP is a tip 42C. Anyway, it's running quite well actually. I've got the voltage back up to almost 0.5 volts, which is what I was getting with an AC transformer that was down here, which was at 50 Hertz, which was consuming a whole lot of power, like 700 milliamps. The transformer was consuming actually 500 milliamps, half an amp, and there was another 350 milliamps of current being drawn by the actual circuit, which was driving our coils. Well, you'd be surprised to learn that right now, this particular circuit down here on this breadboard is running off my 12 volt, 11 volt actually, solar battery lamp, which is running off the solar battery actually, and that's drawing. This circuit down here draws 22 milliamps, and I'm also drawing the actual voltage for the this particular output stage is being drawn from a separate supply, which is over there, which is set to 20 volts. So this is running at 11 volts, this circuit down here, and I'm shunting in 20 volts on this yellow wire, which is coming in. Forget the capacitor, I'm just using that to clip my thing onto. It's not actually in the circuit. So I've got the 20 volts coming in down this wire onto this other rail, which goes to the collector of the tip 42C, and that is switched on, and it does get quite warm, but it's not hot. It's actually running quite cool now, and it actually drives the circuit, and the resonant frequencies actually are very good. Oh, I'm getting a lot of strobing on here. So I've got two mixed frequencies. What you're seeing there is a square wave, which is basically outlined by the other frequency, which is locked in the middle. Sorry about the strobing. It's the frequency of the scope. And also the intermixed frequency, which is the smaller waveform riding on top of it. Now, the reason for having two frequencies is quite simple. I want to use the resonant frequency of a primary coil, which is the primary coils are at the ends. I want to optimize the primary frequency for those primary coils, right? So one frequency is to resonate those, and the other higher frequency is to resonate the secondary coil, which is in the middle of the device. So by having two frequencies, I can basically resonate the coils independently. The actuation coils and the secondary coil can resonate independently. Now, the only drawback, I mean, I'm only consuming 100 milliamps actually off a 20 volt supply, which is, I don't know if you can see it, it's on a 100 milliamp scale. I can't get over there right now, but it's on the 100 milliamp scale anyway. Now, the only drawback is, whereas before I was getting about, I think, on the output, on current, I can't remember now, I think it was somewhere around about 40 milliamps output or something. But anyway, at the moment, my current output is actually quite low. It's about 6.7 milliamps. Well, okay, no biggie, no big problem. We're progressing. There's a lot of tweaking still to do with this device. Obviously, there's more. I've got another build to come up with a more better coupling between the magnets, and but I mean, the thing is, I've got the current consumption way down, and we're also the circuit works, which I built down here, which is going to go on a PCB, which is going to be etched at some point soon. This is a rough idea of what the layout will look like. This is actually one of my plans, but I'm going to be changing the transistor configuration of the power output anyway, because I'm going to be rewiring those at this top end here and there. So that's going to get swapped around a bit. These two here, Q1, Q2, they're going to get swapped around, but so I've got a few legs to reroute and things. But apart from that, the circuit works. It's just a question of fiddling and tweaking and doing all sorts really to get things working. So anyway, at the moment it's drawing 6.7 milliamps on the secondary coil. I can't detect any noticeable change on the input on the drive circuit on the scope. So if I change this back to volts, it's actually on volts now. We're not seeing any change on the drive circuit whatsoever, even though it's coupled with a capacitor. So that's basically this 12,000 microfarad capacitor is coupling the output from these transistors to it's going up with that red white top bar, then it's clipped onto a resistor there. It goes to that red wire. I've lost where the end of it goes. It goes over there, all the way around and up here. to the input coil, and the other coil obviously is connected, the other end of the coil is connected to ground, and that's the green wire, which basically comes all the way around over here to ground. So anyway, thanks for watching.